In this video, we'll be looking at the Pythagorean Theorem and its converse. The Pythagorean Theorem is a squared plus b squared equals c squared. So we all remember that, but we need to know how we can actually apply it. We use it to find the missing side of right triangles. So to make sure that you're using it properly, you need to make sure that you're dealing with a right triangle. Typically, it'll be marked with the right angle in the corner here, and then we look for the hypotenuse and the legs. The hypotenuse is always directly across from the right angle. So since the right angle is in the bottom left here, we look upright towards the hypotenuse there. So this is our hypotenuse. It's always going to be the longest side of a right triangle. And we use the letter C when we talk about the Pythagorean theorem for the amount of the distance of the hypotenuse here. The legs always build the right angle. So you can think of it as an L for legs makes that right angle shape there. So these are the legs, and you can label them both A and B. It doesn't matter if you choose to make the left side A, the bottom B, or if you switch them. As long as those are both an A and B there, and you're not making them C, it's fine either way. So we're going to use that to find these missing sides. In the first example, we're given that A is 5, C is 7, and B is something that we don't know. So we're going to use the a squared plus b squared equals c squared formula. And we're going to say that this was given as a right angle. I should have marked that. I apologize. We are assuming that these are right triangles. So we'll change those directions up on the final draft of these notes. A squared plus b squared equals c squared. We're going to replace the a with a 5. The b is something we don't know, so we're going to leave it. And the c is being replaced with a 7. So we're going to go through and evaluate this and solve for b. 5 squared is 25, b squared stays where it is, and 7 squared is 49. So to subtract 25 from each side, we'll get that b squared all by itself, and that leaves us with 24. To undo a square, we're going to have to take the square root. That leaves us with b equals, and the square root of 24 is not a perfect square. However, we can recall that we can simplify radicals by breaking it up into factors of perfect squares. So since 24 is the same as 4 times 6, well, the square root of 4 is 2. So when we rewrite the square root of 24 as the square root of 4 times the square root of 6, remember that we can break it up like this because of the rules of radicals, and the square root of 4 is 2. The square root of 6 stays how it is. So that is the most simplified version of the length for b. So we would say that b is 2 root 6. In the second question, we have a equals 2, we have b equals 6, and c is unknown. So we're going to use the Pythagorean theorem here for a squared plus b squared equals c squared. A is 2, so we write 2 squared plus our b, which is 6 squared, equals c squared. In this case, we just have to evaluate this. So 2 squared is 4, 6 squared is 36. So c squared will equal 40. And then to get the c alone, we have to take the square root of both sides. So the square root of 40 would not be fully simplified, so we want to break 40 up into its factors. 4 times 10 lets us see that we have a square root there. So really that's going to be the same thing as taking the square root of 4 times the square root of 10, which gets us 2 root 10 equals c. So that'll be our length of our hypotenuse for this triangle. In this question, we're asked to find the length of RT. Well, as you can see, RT is this entire side, one of the legs of the large triangle here. But we also have a second triangle sitting within the small triangle, and this smaller triangle, we know a leg of 12, we know a hypotenuse of 20, so we can use the Pythagorean theorem here to figure out, well, what is this side A going to be? Because I know a leg and I know a hypotenuse, so I'm going to use the Pythagorean theorem on the triangle QST. So a squared plus b squared, which is 12, will equal c squared, which in this case is 20. So I'm going to solve for this missing side first. We subtract 144 from each side, so a squared will equal 256. And then we will get the square root on both sides, so a equals 16. So since a is 16, now I know the leg of the larger triangle down at the bottom there is 16, and I know the hypotenuse of the larger triangle is 65. So I'm just missing a leg. So now I'm going to call that B, that's our blue side, RT, that we were asked for in the problem. So I can just use the Pythagorean theorem again, but on the larger triangle, and say that 16 squared plus B squared will equal 65 squared. And that's going to help us find that missing side length. So 16 squared is 256, and 65 squared gets us 4,225. Sorry for the delay. So we're going to take 256 plus b squared equals 4,225. We subtract 256 from both sides, and we get a difference of 3,969. We'll take the square root on both sides, and when you do that, it turns out that b equals 63. So that means that the length of RT is 63. We're going to now use the Pythagorean theorem to solve these word problems. So we're going to try to draw pictures and find right triangles in order to apply this Pythagorean theorem. So drawing the picture is going to be key in helping you kind of understand why are we using this. So it says use the Pythagorean theorem here. The top of a ladder is leaning on a building at a point 12 feet above the ground. The bottom of the ladder is 5 feet from the base of the building. What is the length of the ladder? So I'm going to draw the picture. Here's our building. It's sitting on the ground, and there's a ladder leaning up against it. In the problem, it says that the ladder is at a point on the building that is 12 feet above the ground. It's also at the base of the building 5 feet away from it. So that means the distance from the ladder to the base of the building is 5, and the distance from the ground to the top of the ladder is 12. And we want to know what is the length here, x. So because you can see we have a building sitting on the ground, that's going to create a right angle. So we have a right triangle sitting here, and the legs are 5 and 12, so we're going to calculate what is the hypotenuse x there. So we're going to take 12 squared plus 5 squared and set it equal to x squared. 144 plus 25 equals x squared. This equals 169. We'll take the square root of each side, and we get 13 equals x. So that means that the ladder is 13 feet long. In the next question, it says you've just picked up a ground ball at first base, and you see that the other team's player is running towards third. How far do you have to throw the ball to get it from first base to third? The distance between each base is 90 feet. So we're dealing with a baseball diamond here. And a baseball diamond is going to be, it's going to have these 90-degree angles at each base and at home plate. So I'm going to label this with an H for home. This would be first, second, and third. This problem is saying that you are on first trying to get a ball all the way over to third. So we want to know what's the distance right here. And so I'm going to call that x because that's what we're looking for. The other information that's helpful here is that the distance between each base is 90 feet. So every side here is 90. And so we can use that. We've got right angles, and so 90 and 90 are both the legs. So to find the length x, that's our hypotenuse, we're going to say 90 squared plus 90 squared is going to equal x squared. Well, 90 squared is 8,100. We add it to itself, and we get 16,200 equals x squared. Take the square root on both sides, and we get approximately 127 and 3/10 rounded will be equal to x, and we're going to put a label of feet on there to say that that would be the distance from first to third base. In this last word problem, it says the diagonal of a square is 16 centimeters. What is the length of one side of the square? So I'm going to draw a square. In a square, the diagonal goes from one corner to an opposite, so you can draw it either way. I'm going to draw it here and say that if that's my diagonal, I want to know the distance of it, so I'm going to call it x. The diagonal is given to us as 16 centimeters. We want to know the length of one side of the square. Well, if it's a square, then that means that all sides would be the same, so I'm just going to call them all x. That means I have two right triangles here that are building this diagonal. The legs are both x, and 16 is the hypotenuse. So to use the Pythagorean theorem, I would take x squared plus x squared equal to 16 squared. So if I have an x squared plus another x squared, that's really 2x squared equals 256. We divide both sides by 2, so x squared equals 128. When we take the square root of that, we can simplify this. Even though it's not a perfect square, 128 can be broken up into 64 times 2, and the square root of 64 is 8. So this can really be simplified to the square root, 8 times the square root of 2. Now the last thing that we're looking at is using the converse of the Pythagorean theorem. It says that if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. And then to follow up with that, if that longest side is less than the squared sum, the square of the longest side is less than the sum of the squares, then that'll make an acute triangle. But if the longest side squared is greater than the sum of the squared of the legs, then it's going to form an obtuse triangle. So we first need to, when we try these, check, does the triangle exist? So we need to check our triangle inequalities. Once we know whether the triangle exists, then we can test to see whether it's right, acute, or obtuse. So these are my three sides. Just to check to see if this makes a triangle, remember we have to add 2 of the sides and make sure that it's greater than the third. So 7 plus 24 would be greater than 25. 7 plus 25 would be greater than 24. And 24 plus 25 would be greater than 7. So our triangle inequality works for all three sets there. So we know that this does form a triangle. But then we have to use this variation of the Pythagorean theorem to determine whether we have a right triangle, an acute triangle, or an obtuse triangle. So if this would be a right triangle, then the longest side would be the hypotenuse, and that's our C value every time. So I'm going to identify that as 25 here, and that means that A and B are 7 and 24. So I'm going to take 7 squared plus 24 squared and say, compare that to what 25 squared is. 7 squared is 49. 24 squared gets us 576, and then we're going to add them together and we get 625. Well, 25 squared is also 625. So because those are equal, this is a right triangle, since A squared plus B squared does equal C squared. In the next one, we have 4, 4, and 8 as the potential sides of a triangle. When we start checking our triangle inequalities, we can see right away that if I add 4 and 4 together, I get 8, and it's not greater than 8. So this does not form a triangle. So we can't even test to see what type of triangle it is because it can't make one. In the next problem, we have 4, 7, and the square root of 43. Well, the square root of 43 is not a perfect square, but we know it's a little bit less than 7 because the square root of 49 is 7. So this would be about 6.4 probably, we can estimate. And we can see that it won't be the longest side, but it also helps us kind of estimate and try these triangle inequalities. 4 plus 7 would be greater than about 6.4. 4 plus the square root of 43, or about 6.4, would be greater than 7. And 7 plus the square root of 43, which is about 6.4, would be greater than 4. Sorry, wrote the wrong thing. So greater than 4. So because those all pass, we know we could at least have some sort of triangle here. We're going to use this up top, the converse, to test whether it's a right triangle or not. So the longest side in this triangle would be 7. So A is going to be our 4, and B is going to be the square root of 43. We're going to put it in exactly as it is, and we're going to square that. And then our C is 7, so I'm going to square that on this side. 4 squared is 16. The square root of 43 squared is just 43. The square root and square cancel each other out. 7 squared is 49. 16 plus 43 makes 59. So since 59 is greater than 49, we're saying that the sum is greater than the longest side. So since the sum is greater there, that's going to make an acute triangle. And what that would kind of look like, if you wanted to sketch it out, would be something like this, where the shortest side was 4, the longest side was 7, and the square root of 43 is a little bit shorter than the side of 7, but they're pretty close, so it's kind of looking like it's creating close to an isosceles triangle. We're not quite there, but those two top sides are a little bit They're very close in length to each other. And we can see that none of those angles are obtuse, so this is going to be an acute triangle. In the next one, we have 5, 8, and square root of 26. So 5 plus 8 would be 13, which is greater than the square root of 26. Remember, square root of 25 is 5, so this radical is probably about 5.1 if you were going to estimate it. 5 plus the square root of 26 would be greater than 8, because that would be probably a little over 10 there. And then 8 plus the square root of 26 is definitely greater than 5. So it passes the triangle inequalities rule. The longest side here would be 8, and 5 and square root of 26 would be our shorter two sides. So we're going to take 5 squared plus the square root of 26 and square that. And then we're going to see, does that equal, or how does it compare to the longest side squared, which is 8 squared. So 5 squared is 25, the square root of 26 squared is 26, 8 squared is 64. 25 plus 26 is 51. So 51 is less than 64, which means that in this case now, our sum, which is over here, is less than our longest side squared. So that means we have an obtuse triangle. And what that would look like if you were going to sketch this one is that we would have a side of 5, a side of the square root of 26, which is about 5.1, so they're going to be pretty close in length, and then we have this longest side, 8. So this is that obtuse angle formed right up there, which makes this an obtuse triangle.